What if everything you have ever touched, seen, or imagined is not made of atoms or quarks or even energy, but of tiny vibrating strings hidden deep beneath the fabric of reality? What if the universe is not built from particles, but from pure vibration? And if this is true, then what does it say about space, time, gravity, and the very limits of human existence? Today, we explore string theory. Not the popularized myth, but the real scientific attempt to describe the true blueprint of the cosmos. Before we dive deeper, make sure to hit like and subscribe to Deep Space Explained so you never miss the mysteries shaping our universe. Physics has a secret war. Two theories rule the cosmos, but they refuse to agree. On one side is general relativity, Einstein's masterpiece, the theory that describes gravity, planets, stars, galaxies, and the shape of spacetime itself. On the other side is quantum mechanics, the bizarre set of rules that control the micro realm, electrons, quarks, photons, and the chaos beneath reality. Both are incredibly accurate. Both describe their worlds with astonishing precision. But together, they fall apart. Whenever scientists try to combine gravity with quantum physics, the math explodes into meaningless infinities. So physicists asked a radical question. What if the fundamental pieces of reality are not point-like particles, but tiny strings? Keep that question in mind. It will tie directly into a mystery we will return to soon. Imagine zooming into a particle. Past atoms, past nuclei, past quarks. Zoom further until even the concept of size loses meaning. According to string theory, at this unimaginable scale, you wouldn't find a point. You would find a one-dimensional string, a string that vibrates. And just like the vibration of a guitar string produces different notes, the vibrations of these cosmic strings produce different particles. One vibration becomes an electron, another becomes a quark, another becomes a photon. And one very specific vibration produces the most elusive particle of all, the graviton, the hypothetical carrier of gravity. This is why string theory elegantly unites gravity with quantum physics. Gravity doesn't need to be forced into quantum mechanics. It emerges naturally from the vibration patterns of these strings. Here is where things get strange. For the math to work, strings cannot vibrate freely in just 3 dimensions of space. They require additional dimensions. Not metaphorical dimensions, literal ones. String theory proposes that the universe contains 10 or 11 dimensions, depending on the version. So, where are they? Imagine each point in space as a tiny curled-up shape, so small that even the most powerful microscope in the universe could never resolve it. Just like a cable appears one-dimensional from far away, but reveals thickness when viewed up close, our universe might hide entire dimensions folded into every point around you. These hidden dimensions are called Calabi-Yau manifolds, extremely complex shapes that determine which vibrations are possible. And those vibrations? They dictate what types of particles and forces can exist. Meaning, the very shape of these invisible dimensions defines the laws of nature. If the folded geometry were different, your universe might contain different forces, different particles, or possibly no life at all. Strings are just the beginning. In advanced versions of string theory, known as M-theory, strings can also expand into higher dimensional objects called branes. A 2-dimensional brane is like a cosmic membrane. A 3-dimensional brane is like an entire universe. And we might live on one. Some cosmologists believe that our universe is a brane floating in a higher dimensional space, sometimes called the bulk. Other branes may exist parallel to ours, each with its own physical laws, separated by a distance so tiny we cannot perceive it. And if these branes collide? Some versions of string theory say that such collisions could create a Big Bang. Not the Big Bang, a Big Bang, meaning universes could be born through the dance of vibrating branes in higher dimensions. String theory is beautiful. Many physicists say it feels like the universe should work this way. But there is a problem. String theory has not yet made a testable prediction. We cannot directly observe strings. We cannot detect higher dimensions. We cannot measure gravitons. The energy required to see any of this is so high that even our most powerful particle accelerator, the Large Hadron Collider, is far too weak. Some critics argue that string theory is elegant mathematics searching for experimental evidence that may never come. Others counter that the theory is so comprehensive, so mathematically consistent, and so physically compelling that we should expect evidence in indirect forms, such as gravitational wave patterns or cosmic background anomalies. And this leads us to one last mystery. If everything is made of vibrations, then what is vibrating? A string is not made of matter. It is not made of energy. It is not made of particles. A string is made of pure information. A string exists because mathematical consistency demands its existence. It is the most fundamental concept the universe can support. This leads to a profound idea. Perhaps the universe is not a physical object, but a mathematical structure. And matter is simply the manifestation of vibration patterns in that structure. You are not made of particles. You are not made of atoms. You are made of notes. You are a symphony of vibrating strings playing a cosmic melody. And the universe is the instrument. So, the next time you look up at the night sky, remember this. Every star, every galaxy, every black hole, every atom in your body, all of it may be part of an unimaginable orchestra where the smallest players are strings vibrating through hidden dimensions. If this exploration opened your mind, drop a comment below telling us what you think the universe is really made of. And share this video with someone who loves cosmic mysteries. To keep traveling deeper into the unknown, watch the next video on screen now. This is Deep Space Explained, and the universe is only getting stranger.